Last week, in part 1, we featured the story of Mark's successful one-year solo Atlantic circuit. What made his voyage remarkable was that he was a relative beginner to offshore sailing, and he did it on a Cape Dory 36 equipped with a low-output electric motor. This time we'll focus on what equipment performed well and what caused trouble along the way. Most gear reviews are done by people who just unboxed an item or received sponsored equipment. That won't tell you how it functions in the real world. This is an unbiased report on the items we installed to prepare this boat for back-to-back single-handed Atlantic crossings to show you what worked, what broke, and what we would do differently next time.
I think in terms of risk, there's health risk of injury or risk of sickness, of course. Then there's weather-related risk, and then there's other types of risk, one being equipment. And I was lucky not to have health issues. I was lucky that the weather issues and challenges that I faced were in the end, very manageable. But wow, I encountered a lot of equipment issues along the way, as most other sailors seem to. I count myself lucky because the most serious equipment failures I had, I was either able to deal with a quick jury rig underway, or the most serious one that happened didn't happen at a critical time. I was either just arriving to port or still in port and had a chance to correct them before I left.
Mark carried a 44-pound, 20-kilo Rockna primary anchor with 150 feet of 3/8 G4 chain spliced to 100 feet of 3/4 nylon rode, and 2 secondary anchors, an 18-pound aluminum Guardian and 26-pound Fluke type, and they all worked well. Before the Atlantic circuit began, Mark had a problem with his Lofrans Royal Manual windlass that was less than 2 years old, though it did have heavy use during a winter in Bahamas and a cruise up and down the U.S. East Coast. The issue could be that he did not use a canvas cover or rinse it off with fresh water from time to time, coupled with a design flaw where the plastic shaft bushings swell and increase the friction of operating the hand crank until eventually you can't turn it. Mark had a time crunch, and because some of the stainless fasteners for the cover plate were seized with corrosion and he did not have the right tools to repair it at anchor, he decided to replace the windlass. Then he covered it and rinsed occasionally after use and has not had further problems. Later, I was able to disassemble, drill out, and retap one frozen screw, sand some extra clearance in the bushings, and reassemble with anti-seize compound on fasteners, and it's back in working order. If you know of any other brand of small manual windlass being produced, let us know in the comments. On the first leg of his Atlantic crossing, a few days out from Bermuda, an outhaul shackle on the aft end of the boom broke, but was an easy fix to replace underway with his spare. Here are the blocks on the boom for the slab reefing to 3 reef points. The Tides Marine low friction mainsail luff track made the mainsail easy to hoist and even reef going downwind. People have reported that the black plastic track degrades from the UV exposure and low latitudes and may need replacing in as little as 7 years. But at least the expensive special stainless slides can be reused if you order a replacement track. Shows a battenless mainsail for simplicity and low cost and easy sail handling. So how's that worked out for you? You lose a little bit of sail area, but you can make up for it either with the asymmetric spinnaker downwind and your Genoa, which is a little larger than Yankee would be.
Yeah, I found the main to be great. I had no issues whatsoever. It goes up like a charm very easily, and it comes down very quickly, and without any battens, it's very quickly to get down and stowed.
Yeah, and that Tides low friction track helps out.
That's a tremendous help.
One thing he had happened that by the time he got to Bermuda, he saw that near the tack on the furling Genoa at the luff, that because there was this long distance unsupported here to the bolt rope, that because also if the halyard tension wasn't quite enough, that there was a strain here. And so this got torn loose a little bit. So in Bermuda, he had the sailmaker put a little strap on there that he could secure this around the foil and therefore give it some support. And so a sailmaker, and he did a repair patch there. So,
But look at this.
a sailmaker can anticipate that by putting in maybe a Velcro webbing there, so that wouldn't happen in the future. Somewhere in mid-Atlantic, a rubber spreader boot came loose and caused chafe on the Genoa leech. He patched the sail, but on the final leg of the voyage, a large section of the Sombrella UV strip came loose. Because it was sewn together with the leech sailcloth tabbing, the tabbing also came loose. The sailmaker could have sewn these separately, which is what we are doing now to repair it ourselves. And then there is UV damage to the threads along the UV strips on the furled sail where it's been constantly exposed for 4 years in mostly low latitudes, so is due for restitching there. This is common if you haven't paid extra for UV-resistant Tanara thread. His sails were supplied by Discount Asian Loft Raleigh Tasker National Sails, who have an agent based in Florida. The quality has been good for the most part, but you might expect some compromises on sails that cost much less than what the U.S. sailmakers have quoted. Mark felt that sailing the boat mainly with the 135% furling Genoa with foam luff worked better than using the smaller original Yankee that requires using it together with a staysail and light air. On occasion, he did fly both together, but that was mainly when rising winds were expected in order to be prepared to carry on under staysail alone, simply by furling the Genoa. His battenless main with 3 reef points, storm jib, and asymmetric spinnaker in a sock all performed well. He experienced some chafe where the jib halyard passed through the Harkin halyard restrainer, so after each long passage he inspects it and, if needed, cuts out about a 6-inch chafe section near the shackle and reties the halyard. It's good to have a bit of extra length on your new halyards in case you also need to shorten them later. He also had chafe on the wire loop of his whisker pole. He replaced that broken wire with a loop of line. He often uses 2 downhaul lines to keep the pole immobilized so he can let the Genoa sheet run free through the jaw of the pole, and that way the pole does not swing around when he's furling or unfurling the sail. So that the sheet can safely be attached to the pole, he furls the sail first and then attaches the sheet to the pole, then deploys the pole and secures it. Now he can unfurl the sail without fighting to set up the pole under load. Also, he found it necessary to rinse the pole after each passage and lubricate it to prevent its extendable feature from sticking. To avoid needing someone to winch him aloft, Mark uses a mastmate nylon ladder. It's easy to use, though it does take some setup time. For safety, he wore a climbing harness that he tethered to an adjacent halyard. He also had a bosun chair he could use for more comfort while working aloft for extended periods. For a dinghy, Mark has an inflatable Takacat 260S that has an innovative open transom design with inflatable floor to save weight. It has stood up fairly well to frequent use, aside from him needing to reattach the rub rails with 5200 adhesive while in the Azores, and to repair a leaking valve. Next time I would consider a similar lightweight design dinghy called the True Kit, which reportedly has better quality materials in construction, such as its German Valmex fabric rather than cheaper Asian PVC, and its seams are welded rather than glued, and it has an aluminum plate transom for more rigidity and a drier ride than the Takacat open transom. His ePropulsion Spirit 1 Plus electric dinghy motor was quiet and performed well, so it's easy to see why so many people prefer that to a noisy gas motor. Then it got damaged when a power plug on top of the battery was somehow stove in when he left it at a dinghy dock in Dominica. Since then, he rows the dinghy ashore and also has an inflatable kayak available. After arriving in the West Indies, Mark ordered and paid for replacement parts for the motor using Annapolis Hybrid Marine, but for 2 months now they did not ship the part or refund his money or answer emails or voicemails from either of us. So consider that if you're looking for a U.S. ePropulsion dealer. Not wanting the complexity and intrusive systems and maintenance of a diesel engine, during the refit, we removed the ailing, oil-dripping diesel and constructed an outboard well that could handle either a 9.8 horsepower gas outboard or a 6 kilowatt ePropulsion electric outboard. For his voyage, he did not require the longer motoring range of the gas motor and did not use it, although it was aboard as a backup. This low-powered 6 kilowatt motor turned out to give the equivalent performance of about a 9 horsepower gas motor and performed as well as our previous sea trials had shown. The top speed in a calm was 5.7 knots, but he could greatly increase his range by going 4 knots while using only 2 kilowatts of power. While motoring at around 5 knots, the motor well does not experience any flooding, but when sailing fast at 6 knots or more in waves, the stern of the boat squats more and causes the motor well to hold a few inches of water over the cover boards. So on a long passage, Mark covers the motor to protect it from splashes. The only issue the motor had was when entering port in Agadir, Morocco. Mark noticed the cooling fan inside the outboard was not functioning, probably due to corrosion. The broken fan was not critical since he could still motor into port, but running it a long time at high throttle could have caused overheating. The fan is vulnerable to corrosion due to its close proximity to the water, which is a motor design limitation because the motor head needs ventilation for cooling, and that naturally allows moisture to get in. At least his motor well is protected from waves within the lazarette locker to keep corrosion to a minimum. On final approach to Cape Verde, Mark's partly furled Genoa suddenly unrolled and forced him to drop the sail and enter under staysail. It turned out the lower plastic drum flanges on the Harken Mark IV Unit 1 furler had broken and some screws had vibrated loose. It was fairly simple for him to remove the broken parts and rejoin them with 2 scrap metal plates and bolts. But then he discovered a second fault. Hidden under the upper plastic flange, and not described in the parts diagram, were 4 set screws that connect the furler drum to the foils. The factory may have neglected to add high-strength Loctite to those 4 screws, which allowed the foils to spin free of the drum. Once those screws were resecured, the repair was complete. The patch repair on the furler appears stronger than original, and he completed his Atlantic crossing with it. If you have a Harken, I would disassemble these components and apply fresh Loctite, and consider carrying a spare set of drum flanges. I've used Harken furlers for years on my boat without issues, but going forward I would recommend a furler that doesn't use plastic in such a critical area.
So I have 2 self-steering systems. One is the Pelagic Autopilot. One is the Monitor Wind Vane. The Pelagic is for lighter winds and also for entering and leaving anchorages in tight quarters. The Wind Vane is really for offshore and in slightly higher winds, and it's what I rely on really for all of my offshore sailing.
While in port in the Cape Verde Islands, Mark discovered a crack in the latch holding the hinged rudder or servo oar on his Monitor Wind Vane. If not noticed, it would have broken off and disappeared in the sea on his next long passage to the West Indies, and it would have been very awkward to jury-rig at sea. Since he was in port, it was a simple matter to take the cracked bracket to a local metal fabricating shop where they welded a reinforcement plate onto the crack. This highlights the importance of frequent and thorough inspections of all critical equipment. For light winds, when the Monitor struggled to steer, his Pelagic Autopilot, although noisy, performed well. For those who plan to cross an ocean with only their electrical autopilot, I would advise they carry a complete spare unit with them and have the knowledge and skills to replace it at sea. His non-pressurized Origo alcohol stove was a safer, more compact alternative to the typical propane system carried by most yachts. He carried enough denatured alcohol with him to last the voyage, but inexpensive alcohol is hard to source in some countries. A possible solution is to only use the alcohol stove at sea, and when in port, use a portable induction stove, since with the solar and a large battery bank, he normally has way more power than he can use in port. Swan has 3 water tanks holding a total of 75 gallons going to a simple foot pump with no water-wasting pressure pumps or water heaters. He uses a solar shower in the cockpit and can also use a modified garden sprayer for a sit-down shower in the head. When we modified the cockpit to convert from wheel to tiller steering and fit an outboard well in the lazarette locker, we also reversed the slope of the footwell to eliminate seacocks and drain out the transom above the waterline. Mark found the simplified and intuitive feel of the tiller entirely preferable to wheel steering. And we enclosed the rudder shaft in a watertight locker with gasketed access panels. Later, we replaced the leaky stuffing box and raised it above the waterline. Over at the navigation station, Mark carried 2 Garmin InReach satellite text communicators with updated map sharing for his followers ashore. On the Atlantic Circle, one of the devices went offline on the map share function for a few days, although his messaging was never interrupted. Many sailors carry the Starlink Mini for full internet access, including voice calls, but Mark needed an InReach device anyway for emergency comms he could take with him to a life raft, and he did not want another subscription service with monthly bill or the tempting intrusion of internet distractions. Mark's modest 400 watts of solar power kept up with his usage, running a portable fridge, nav equipment, lights and fans, inverter, VHF and AIS, chart plotter, computer, and so on, and occasional brief runs of the electric outboard, mainly to get in and out of port. We set it up so that the solar charging was switchable between his 200 amp hour 12 volt or the 175 amp hour 48 volt banks, and excess power from the 48 volt battery could charge the 12 volt house bank if needed. Here is the battery compartment, and he has the 48 volt battery for the electric motor there on the left, and on the bottom right is a 200 amp hour house bank 12 volt battery, and then up above it is an emergency battery in case lightning or some other BMS fault happened in the 12 volt house battery, that he could connect up this emergency 50 amp hour 12 volt battery, but normally it would be offline, just sitting there in reserve. When possible, I prefer standalone equipment for redundancy. For example, I like to have a second depth sounder with dedicated display so that if the chart plotter goes out with its transducer, I can use the other one. Also, on extreme heel, the transducer on the lee side may be more accurate than the windward one. Instead of an expensive combined shore power inverter charger, as is standard on most boats of this size, we used an individual battery charger and separate 1500 watt inverter that are simpler to troubleshoot or replace and cost much less. Across 11,000 miles of open water sailing, Mark experienced the full spectrum of marine maintenance, from expected wear and tear to a few potentially serious breakdowns. As Mark stated in the intro, luckily none of the more serious problems occurred during critical times or in mid-ocean. A big takeaway, aside from the need for proper passage planning, wasn't about the latest gadgetry, but having proven simple systems you can repair underway. That means carrying the right tools and critical spares. But as this voyage proved, parts alone aren't a guarantee. Out on the ocean, Safety isn't only about what you can buy. It comes down to what you can fix, the skills you've learned, and the understanding of what you can do without. You can share your own concerns and stories about equipment problems in the comments so we can learn together.